Okay, so all this discussion just means there are three ways that f could not be differentiable. If you have a vertical tangent, looks like that. If you have a cusp, looks like that. If you have a discontinuity. And it could be any of the kinds of discontinuities, so it could look like that, or it could look like that, or it could look like that, or it could look like that. You know, all the usual things. Any way that a function could be discontinuous. All right, so now you're going to apply that and say, look at this nifty function. Now, just eyeballing it and sort of assuming that everything is what it appears to be, your job is to answer this question. So for this graph shown above, at what points is f not differentiable? Justify each statement. And at what points is f not continuous? Justify each statement. So you should pause the video so you can look at that function and answer these two questions now. Pause and answer. Okay, I'm going to assume you have now paused and answered. So, at what points is f not differentiable, and we need to justify each statement, okay? So, right here I see a cusp. So, at x equals -2, and the reason is because f, I really should say the graph of f. I'll say that. The graph of f has a cusp. That's all you have to say for a complete justification. Okay, where else is this function not differentiable? This function is not differentiable at x equals 0. Reason, f is not continuous at x equals 0. I mean, we should always say at x equals whatever for all our justifications, okay? On this one, it's tempting to sort of, this is one of those where you could go back and back and back with justification. All right, f is not continuous because the limit as x approaches 0 does not exist, because the limit from the left is not equal to the limit from the right. All right, but you don't have to go back and back and back. You're justifying one thing. You are justifying f is not differentiable. So all you have to say is f is not continuous. You don't have to say why f is not continuous. So in other words, you only have to give one level of justification. Sure, f is not continuous because the limit as x approaches 0 does not exist, and the limit as x approaches 0 does not exist because the limit from the left does not equal the limit from the right. But we don't have to go back that far, just one step. Okay? All right. But make sure it's the right step, right? So what would not suffice is to say f is not differentiable at x equals 0 because the limit from the left does not equal the limit from the right. Okay? Because you've justified the function is not continuous, but you've not justified that it's not. Actually, you've justified the limit does not exist. You've not justified that the function is not differentiable or not continuous. Okay? So you have to give the most immediate reason. The most immediate reason why f is not differentiable is because f is not continuous. All right, and the third point is x equals 2 because the graph of f has a vertical tangent at x equals 2. And these are the kind of justifications that you need to write if someone asks you to justify that the function is not differentiable. Okay, at what points is f not continuous? Is f continuous at x equals -2? Is f still continuous? Yes, it is. Because there's no, because the limit exists, the limit is equal to the function value. All right, is f continuous at x equals 2? Yes, it is, because the limit from the left, limit from the right are the same. Therefore, the limit exists. The limit is a certain value, which that's 3 or whatever it is, but that's what the function value is. Another way to say that f is continuous at both -2 and 2, there are no jumps, breaks, or holes, right? At -2 and 2, there's no jumps or holes, all right? So f is continuous at -2 and 2. Where is f not continuous? Where there is a jump, which is at x equals 0. All right, so f is not continuous, so f is not continuous at x equals 0. Why? Because the limit as x approaches 0 of f of x does not exist. All right, you don't have to say why the limit does not exist because you're not justifying that the limit does not exist. You're justifying that f is not continuous. One step, the most immediate reason why f is not continuous at x equals 0 is because the limit as x approaches 0 of f of x does not exist. You don't need to justify that because that's not what you're justifying. This is what you're justifying. Okay? Confusing? Yes, but that's what it is. All right. Now, I'm going to give you some, well, let's look at some examples from the book first. So we're going to look at page 114. Got some nice little pictures and stuff. All All right, so if I look at page 114, so I would like to specifically look at number 2. Okay, so I guess I'll reproduce this drawing because otherwise it's going to be, I'll have to keep going back and forth. So they show this, and they show the point 1, 2. So my scale axes are scaled differently. So here's what the graph looks like. And this is the function y equals 2x up here, and this is the function y equals 2 over here. All right, now the directions say, compare the right and left-hand derivatives to show that the function is not differentiable. All right, so this is sort of going back to what I said back somewhere, back here. The limit as h approaches 0 from the left of the slope is different from the limit as h approaches 0 from the right of the slope. So they call this a left and right derivative, which you can do in sort of a way that I hope is clear. But we don't have to, I don't think we need to get quite that rigorous here. What we're going to say is we're going to say that the slope is 0 when x is less than, let's see, it splits at 1, when x is less than 1, and the slope is 2 when x is greater than 1. All right, so therefore, f is not differentiable at x equals 1. So basically your slope from the left and your slope from the right are different. So that limit as h approaches 0 doesn't exist because limit as h approaches 0 from the left, limit as h approaches 0 from the right are different, as we see here. Okay, so that's what I want you to write on those. So like number 4, just to give you sort of a sense of, you know, what kind of things you can write as a justification for these so that we don't go too crazy, because I don't think it's obvious what they want you to write there. So here's a point 1, 1. Strangely, I put it exactly the same point as I put 1, 2. All right, and we have a line going through there, goes through the origin. So we try to preserve some of the qualitative aspects of the graphs, like there appears to be a horizontal asymptote if we go to the right. All right, so, oh, in fact, we know there's a horizontal asymptote as we go to the right because this is y equals 1 over x, and this is y equals x. All right, so we could do something like find the exact derivative of 1 over x when x equals 1. We could do that. I'm going to say that's a little bit of overkill for this, for what we're doing here. So I'm going to say that the slope is equal to 1 for x is less than 1. So we're doing like piecewise slopes, okay? Piecewise slopes. And for x greater than 1, well, here's what I would just say. I would just say the slope is clearly negative, right? The slope is negative. So I would say, just say the slope is negative, like that. And then I can clearly see these two slopes can't be the same. All right. I mean, if you wanted to be super cool, what you could do instead, and I know lots of people in this class want to be super cool, you could say for y equals 1 over x, that's y equals x to the negative 1. So y prime is equal to negative x to the negative 2. So in particular, y prime of 1 would be negative 1 over 1 squared, which is negative 1. And then you could say the slope from at the right is a negative 1. So you could specifically say, as we come up to this point, the slope from this direction is negative 1, the slope from this direction is positive 1. They're different, okay? But I'm going to just say, you could just say it's negative. Did I want to do another one? It looks like I wanted to do number 8 for some reason. Yeah, okay. So oh my God, why did I want to do this? Setting myself up for, I guess I'll do number 8 in the next video though. So you should look at number 8 and see what you think about it, and then I'll put number 8 in the next video.